I'm Jun Lee from 360 Unicorn team. We are very glad to have this opportunity to be standing here on this stage to share with you our talks, our researchers. Let me introduce our team. This is Kunzhe Cai from Texas team. It's a team in 360 focusing on wireless security, wireless penetration tests. And he is the team leader. And this is from Texas team. He's team member of that team, specialized in wireless security. So this ghost tunnel research is mainly contributed by this guy. So let us invite Kunzhe Cai to do a background introduction of this ghost tunnel research.
Good afternoon, everyone. We are very glad to have this opportunity to be here and sharing our research with you. For this research, we named it as Ghost Tunnel. It's about using a covered Wi-Fi C and C means command and control channel to bypass air gapping. First, a brief self-introduction. 360 is a leading internet security company in Asia, like McAfee or Symantec. Our core products are antivirus security software for computers and cell phone. What about our team, Pixas? Pixas is one research group in 360 security technology. We focus on the VLI security and the VLI penetration testing. Okay, first, we will give you an introduction about the air-gapped network and related attack events. Then we will introduce some previous researches on air-gapped attack. After that, we will introduce what is ghost tunnel and how to implement it. Okay, finally, we will show you the last demo. Okay, let me show you what is air gapping. According to Wikipedia, air gapping refers to computers or networks that are not connected directly or indirectly to the internet. And it aims to avoid the intrusion and the data leakage through network connections. Next. Most of the time, air-gapped networks are considered the most secure networks. As we all know, hacks are exploiting vulnerability in the operation system, application software, or communication protocols, and attacking via the internet. However, those does not apply to air-gapped network. Think about this. How do you remotely hack a computer that is even not connected to the internet? Yeah. Air-gapping systems were believed to be more secure in the past, since they required attackers to have physical access to touch them. But for the attacker's perspective, maybe nothing is impossible. They can break through the air-gapping networks via an infected USB flash driver, a special USB device, or an employee laptop. One of the most famous cases involving the infection of an air-gapped system is Stuxnet. Okay, it's first uncovered in 2010, and it targets SCADA system and was designed to cause substantial destroy to Iran's nuclear program. It was burst into the target environment via an infected USB flash driver and spread via USB flash drivers. And according to NSA documents leaked in 2013, countermouth is a USB hardware implant which will provide a wireless bridge into an air-gapped target networks, as well as the ability to load export software onto targets. It will comes with a tiny embedded transceiver. Tiny transceiver. The spy agency can extract and transmit data to a precise NSA relay station up to maybe 7 or 8 millions away via RF signals. In recent years, security research have also begun to focus on air-gapped attack. So let's take a look at some of the previous research.
Okay. The next part is going to be actually to implement the attack and some related research. So this part will be given by Hongjian Cao. Let's welcome him.
Okay. In 2014, researchers at cybersecurity labs at Kunzhe University in Israel has found a way to snoop on a personal computer even with no network connection. The technique works by using FM radio receiver included in some mobile phones. It is able to capture keystrokes by intercepting certain radio emissions from the monitor or display unit of the isolated computer. The researchers can then pick up the FM signal on a nearby smartphone and translate the FM signal into typed text. And it is also the Israeli researchers at cybersecurity labs from Kunzhe University in 2015 have found a new technique to hack ultra-secure air-gapped computers and retrieve data using only heat emissions and a computer's built-in thermal sensor. And last year, CyberX researchers at Black Hat Europe explained how to exfiltrate data via RF signal by attacking Siemens PLCs. They inject specially crafted ladder logic code into a Siemens S7-1200 PLC. Then the code uses memory copy options to generate a frequency modulated RF signal slightly below the AM band, with the modulation representing encoded data. The signal can then be picked up by a nearby antenna and decoded using a low-cost SDR and a PC. Okay, our research ghost tunnel is a Wi-Fi covered channel that can bypass air gapping. So according to pressure events and researchers, we can see attacking an air-gapped network generally takes two steps. The first step is to implant malicious software or hardware to the target system, and the second step is to establish a communication channel to execute commands and exfiltrate data. Ghost tunnel can use a USB HID attack to release payloads into target system, like a Windows laptop. Then the payload uses a built-in wireless network card with a target device to establish a CNC channel with another computer controlled by an attacker. Ghost tunnel establishes the CNC channel via a custom protocol based on 802.11 beacon, probe request, and probe response. And this custom protocol does not affect the victim's normal network connections. For example, the victim still access their internal network. Thus, the attacker can covertly pass commands to target system and exfiltrate data. The victim won't be able to find any anomaly. Ghost tunnel does not require normal network connection, so it can bypass the firewalls, and it has no interference with the target existing connection status and communications. And it supports cross-platform. It can be used to attack any device with wireless network card. We tested this attack on Windows 7 up to Windows 10 and Mac OS X system. And it can work within 50 meters and even further. We know Wi-Fi is a technology for wireless local area networking with devices based on the IEEE 802.11 standards. Using the Euro Wi-Fi communication, a client must first establish a connection with access point like this through a request response process. But Ghost Tunnel does not follow the Euro Wi-Fi connection procedure. That is, we do not use to go through the authentication, association, and all that kinds of stuff. It only uses the beacon, probe request, and probe response frame to communicate. Okay, here is something about the 802.11 state. There are 3 states and 3 frame classes that specify the type of frames that can be transmitted by a client in each state. In state 1, the client is not authenticated and unassociated, and only class 1 frames can be transmitted. Okay. Do you have any questions?
Do you have any questions so far? So if there are no questions, we will go on. Okay.
There are 3 types of 802.11 frame: control frame, management frame, and data frame. As we can see, probe request, probe response, and the beacon are management frame, and they belong to class 1 frame, so they can be transmitted in every state.
So notice that the class 1 commands can be transmitted without authentication, so so that's just before the normal the Wi-Fi connection. So it requires no password, whatever info you even. So let's go on.
Okay. When a client scans the available wireless networks, it can use 2 scanning methods, active scan and passive scan. During an active scan, the client radio transmits a probe request and listens for a probe response from an access point. With a passive scan, the client radio listens on each channel for beacons sent periodically by an access point. So we can use a probe request, probe response, and beacon to create a covered channel. First, the attacker creates a fake AP with a special SSID, and then the attacker can target and the target device use it as an identifier of the communication instead of the MAC address or the BSS ID. Thus, the attacker can receive data through a probe request from the target device, and the target device also can receive data through beacon or probe response from the attacker. Okay, let's see how the ghost tunnel is implemented. Okay, first we need to know the format of the 802.11 frame. There are 3 types: management frame, control frame, and data frame. The general format of management frame is shown in the figure. It consists of 2 parts: frame header and frame body. As the length of the frame body is a variable, so we can use the frame body of the management frame to carry data. The body of the measurement frame consists of fields and information elements. The fields lengths are fixed, and the length of the information element is variable. So we use the information element to carry data. The elements are defined to have a common general format consisting of one octet element ID field, one octet length field, and a variable length element specific information field. Each element is identified by element ID. The length field specifies the number of the octets following the length field. External use the information section of the SSID element and Wonder specified element to carry data. The SSID element identifies the identity of ESS or IBSS. It is the name of the network. The SSID field can be used to carry payload, and the length of the SSID field is between 0 and 32 bytes. Element ID 221 specifies the Wonder specific information element. The organization identifier field contains a public unique identifier assigned by the IEEE. It identifies the entity that has defined the content of the particular Wonder specific element. These fields can also carry external payload data. Okay, now the key problem is how to send and receive 802.11 data frames through local wireless network interface in user space. We know the client's wireless network interface can work in several modes, such as the master mode, managed mode, and the monitor mode. And it generally works in managed mode. In this mode, only fake Ethernet frames translated from the 802.11 data frames can be exposed to upper protocol levels. So we cannot send and receive 802.11 data frames by raw socket in user space.
So we have tell you all about all the basic ideas of a ghost tunnel. If you have any questions so far, you can ask us, because we are going to talk about actually implementation in different operating systems. So is there any question for now? Okay.
The operating system provides Wi-Fi application programming interface to manage wireless network profiles and to manage wireless network connections, such as Windows Wi-Fi API is the native Wi-Fi API. In Mac OS X is a Core WLAN framework, and in Linux we can use the library NL80211. Okay, let's take a look at how to send and receive 802.11 data frames in Windows. The WLAN scan function requires a scan for available wireless networks. It may send a probe request as active scan depending on the value passed in the P.11 SSID and PIE data parameters. P.11 SSID specified the SSID of the network to be scanned. PIE data is a pointer to an information element to include a probe request. if the PIE data parameter is not null, it will send a probe request during the scan. The probe request includes the information element pointed to by the PIE data parameter. D1T1 SSID is a structure contains a SSID. Its maximum length is 32 bytes. The W-line raw data structure contains the element raw data in the form of a blob. Our ghost tunnel payload sent to the attacker can be embedded in them. Once W-scan function is called, then we can call the W-line get network BSS list function to retrieve a list of available wireless network. This process can be repeated periodically to keep tracking of changes to available wireless network. The list of information returned by each wireless network also contain a list of information elements returned by each access point for a network. The information is returned as a pointer to W-line BSS list structure is a PP W-line BSS list parameter. The W-line BSS list structure contains an item count followed by an array of W-line BSS entry structure entries. And the W-line BSS entry structure contains information about a network. URIE offset. This member points to a buffer that contains variable length information elements. From the 802.11 beacon are probe response frames. URIE size, this is the exact length of the data in the buffer pointed to by URIE offset member. Ghost tunnel payloads are embedded in this buffer with the specified element ID 221. In macOS X, it uses Core W-line framework to manage Wi-Fi connections. The scan for networks function in CW interface class is used to scan for networks, but it has no parameter pointed to an information element to include in probe request. So we can only carry data in SSID when send data from a Mac client. After scan for networks function is called, we can call catch a scan result function to retrieve the available networks. It returns a set of CW network class objects. Information element data is one member of the CW network object. That is the information element data included in beacon or probe response frames. The payloads from CMC server is embedded in them. And finally, the ghost tunnel CMC server relies on the modified host APD and host APD CLI. It creates an AP using a host APD. The host APD CLI is a command line terminal that can interact with the host APD with domain socket. We can send commands to host APD. Then host APD forwards these commands to client via beacon probe response. Okay, let's see the attack demo.
So there's no connection. We have used the US HID attack to inject the payload, and the payload is running on the target machine. So we'll pop the calculator to prove that we have control. Then we can okay, we will show the demo on Windows machine. So no internet connection. And then we use HID attack to drop the payload.
你可以说一下，这是 CMD shell， 我们可能会加入更多的功能。
So we just demonstrate how we can get the shell, but we can actually implement more kinds of attack to transmit files on the disk or whatever you want. So we would like to thank you the following researchers. So we would like to add one more, okay, because I think he have done similar research. His name is Marcus Mens. He created a project called POMPI. So we learned a lot from his project. So I will add his name here. Okay.
Thank you very much.
Any questions?
Any question? Okay.
Okay.
何军，你答吧。
Well, first of all, thank you for this talk. Very interesting. I wanted to ask you a question about the delivery of the payload. When you insert the bash bunny...
Oh, sorry, I beg your pardon.
Okay. I was talking about the delivery of the first stage through the bash bunny.
Okay.
So when you insert it, it creates a hid device, let's say, and also does mount any mass storage, or the payload is typed in entirely through the hid device?
We copied the payload to the target machine.
But from the copied. Okay.
有 U 盘的，
就是插那个那个。
对对对。
So there is a mass storage device. So
okay, is mounted when you plug it in. The bash bunny is mounted also the mass storage.
Yes.
Okay, that's what I wanted to ask.
Okay.
Thank you.
Any question else? Oh, that's the one we want to thank. Okay.
Yeah, thanks for mentioning me. First things first, thank you for the great talk. As you stated, our releases are close in technical terms. I have one question. I have many questions actually, but I guess we better discuss outside. But there's one question with matter for the audience, I guess. If you bring up a C2 server on a single Wi-Fi channel receiving the probe requests, are you able to handle multiple servers on the same channel, or how? You stated you are dealing with 265 clients. How
Can you
does
speak
it
more
look?
slower? I'm not keeping up.
Yeah. Okay. If the client is compromised, you can handle up to 256 clients with one C2 server.
Okay.
What happens if two C2 servers come online? Do you handle multiple servers on the channel?
就是我会在 server 的那个去维护一个列表，去在 server 端维护一个列表，然后
We will keep client lists on the attackers in the server. Yeah. Yeah, we'll create a list and add the new clients, the victim, to the list.
Yeah, sure. The question is into the other direction. If two attackers are in place with the same technique, could they run the attack in parallel?
Okay.
以两个攻击者还是受害者？比如说你现在有个 target 上线，两个攻击者电脑上面，然后谁去给他通信？这个可以就是在数据包里边做一些，对，做一个标签啊，标签。这个。
So we can maybe add an identifier in the packets to routing the traffic to routing the certain traffic from certain victim to the intended command server. Maybe.
Okay, thank you. That was the question. Thanks.
Okay. Any question else? Okay, thank you all for attending our talk.